What is going on, guys? My name is Amos and welcome to your second video on sets. So in today's video, we're going to be talking about subsets or parties et sous-ensembles. So whenever we want to mean that every element, let's say we have two sets, all right? Let A and B be two sets. Let A and B be any two sets, be any two sets. So let A and B be any two sets. So whenever you want to signify that every element of the set A is also an element of the set B, well, we can actually use the idea of what is known as subsets, or we can use the symbol for subsets, what we can also refer to as les sous-ensembles et les parties. So for example, if every element of the set A is also an element of the set B, well, we use the symbol A. Then we have that symbol, and now you read it as A is a subset of B, or A is in B. All right. So basically, this is only. So I'm going to give you guys three phrases that you guys have to remember. All right. These are some of the things that you'll be hearing a lot. So we can actually say A est inclus dans B. All right. Or we can also say that A est contenu dans B. A est contenu dans B. All right. You can also say B contient. All right. B contient A. So you basically read it in reverse, that B is going to contain the set A. So these are some of the three phrases that are going to be common whenever we are talking about the idea that every element of a certain set X is, or every element of a certain set A is also an element of another set B. Now, if you're looking for the graphical representation of the concept I'm trying to give you guys, you're going to have something like this. So basically, every element of the set A is also an element of the set B. So we just have this graphical representation of the idea of subsets. Now, if you're looking for a more formal way of writing everything that I've just said, if you're looking for a more formal and concise way of writing that, well, basically in mathematics, we have a tendency of trying to define things like propositions, theorems, and lemmas, basically in form of subsets. So quite alright, I'm talking about A and B alone, or I can actually consider A and B as being subsets of another set. All right, so basically we'll try to do that a lot of times when we're talking about things like propositions. All right, so just keep that in mind. So I'm going to again consider A and B as being part of another set, and I'm going to call that set E. I'm going to call it E. All right, so you basically have quel que soit X dans E, on aura. So whenever X is an element of A, then X is also going to be an element of B. So we basically have implication here. So quel que soit X dans E, so whenever we have X as an element of A, well, that X is also going to be an element of the set B. So now this is going to be a formal way of writing, of trying to express that we're trying to talk about the idea of subsets. Now, you guys, I hope you remember the fundamental examples of the sets that we talked about. So we talked about a set of natural numbers, the set of integers, the set of rational numbers, the set of real numbers, and we also talked about the set of complex numbers. So when we come to the idea of subsets, we have that the set of natural numbers is a subset of the set of integers, and the set of integers is a subset of the set of rational numbers, which is also a subset of the set of real numbers, which is in turn going to be a subset of the set of complex numbers. So this is something that you have to keep in mind. So every element of the set N, or every natural number, is also going to be in the set of integers. Then every integer is going to be in the set of rational numbers. Every rational number is going to be an element of the set of real numbers, and every real number is going to be a set of the complex numbers. So that is what you guys have to keep in mind. You have that formal way of representing that. So now, whenever A is not a subset of another set, let's say B, well, we use the symbol. We use this symbol like so. So we try to show that, okay, A is not a subset is not a subset of the set B. All right. Now this is going to be equivalent to saying, now you guys are already familiar with some of these things from your courses on, or your lectures on propositional logic. Il existe X dans E tel que we have X is in A and X is not in B. So whenever I'm saying that, all right, A is not a subset of B, I'm actually saying that we can find a certain element. So we can find a certain element in the set A. We can find a certain element in the set A that is not in the set B. Well, whenever that is true, then A is not a subset of B. So for A to be a subset of B, all the elements of the set A have to also be elements of the set B. Remember, we had that implication? So all the elements of the set A have to be elements of the set B. Now, whenever there is at least an element that is not in the set A, whenever there is at least an element that is in the set A and is not in the set B, well, we cannot consider A as a subset of B. Il faut que tous les éléments de l'ensemble A, they have to be in the set B. So that is what you guys have to keep in mind. All right. Now, based on what I've said here, let me just give you guys a little mind grenade. So we cannot have something like this, for example. Let's say we cannot have something like Q is a subset of Z. So Q is not a subset of Z. Q is not a subset of Z. Now let me just write that properly. So Q is not a subset of the set Z. Remember, why is this true? Oh, it's because il existe. There has to be there is a certain element that I can find that is in the set of rational numbers that is not in the set of integers. For example, the number 2/3 is in the set of rational numbers, but this number is not in the set of what? Is not in the set of integers. So this is evident because the set of integers is going to be numbers with no decimal points, no fractions there. All right. So we basically have numbers like positive natural numbers and negative natural numbers and 0 there. All right. I hope you guys have gotten it. So Q is not a subset of Z. So because it exists, there's a certain element X that is equal to 2/3 that is not in the set, that is not in the set of that is in the set of rational numbers, and this X is not in the set of what? Is not in the set of integers. So that is also something that you guys have to keep in mind. All right. We have that. And all right, now let me just make a few remarks. So a few important remarks. So the first remark that I'm going to make is that by convention, the empty set is a subset of any set. So the empty set is a subset of any set. The empty set is a subset of any set. Is a subset of any set. The empty set is a subset of any set. Then secondly, if A and B are finite sets, or if A and B are finite sets, and A is a subset of B. So if A is a subset of B, whenever A and B are finite sets, then the cardinality, so if A and B are finite, so if A and B are finite, then the cardinality of the set A has to be less than or equal to the cardinality of the set B. Basically, if A is a subset of B, the number and A and B are finite, then the number of elements in the set A is less than or equal to the number of elements in the set B. And then whenever we have something like A, if we have 3 sets, let's say A, B, and C. So if A is a subset of B and B is a subset of B is a subset of C, well, this is going to mean that A is also a subset of what? A is also a subset of C. So that is all for this video. I'll see you guys in the next video. All right.